Okay, so let's start the second part of the algebra lesson. Right. This is going to be an introduction about functions and their properties. Right. Okay, so to introduce functions, we first have to introduce relations between two sets. We are going to look at four types of relations: one to one to many to one, and many to many. Right. So first, let's look at what? One to one. So one to one relation. So you have set D and set T. There's elements in set D and there's elements in set T. Look at how they are connected. X is connected to 1, Y is connected to 2, Z is connected to 3. So each element is connected to a single element in the other set. So this type of relationship is called one to one. So element in set D can only be connected to a single element in set E. So that type is called one to one, right? Then what is one to many? So as the name suggests, one element can be now connected to many elements on the second set D. So element in set D is connected to multiple elements in set D. This type is called what? This type is called one to many. Then we have many to one. So as the name suggests, many elements in set D can be connected to a single element in set E. So it's given here, multiple elements in set D can be connected to a single element in set D, right? Then the last type is many to many. So multiple elements in set D are connected to multiple elements in set D. So here 1 is connected to A and B, 2 is connected to A and B. So it's many to many then, right? So those are the four types of relations we need to know: one to one to many to one, and many to many. Right. Right. We need to know these four relations to define functions. Right. Now let's define what is a function. Right. So let's go through this definition. A function f is a rule that assigns each element x in set D. So that is the first set, this set. This is very important. Each element in set D has to be assigned how many? Exactly one element called f of x. This is read as f of x. This is read as f of x or function x in a set E. So each element x in this set has to be connected to how many? Exactly one element in fx or set T, right? So this type of relationship is called what? A function. So it has to satisfy that rule. Now let's go back to our four relationships. So look, what is the rule? Each element in set D has to be connected to how many? Exactly one. So look at one to one. One to one follows that rule. X is connected to only 1, Y is connected to only 2, Z is connected to only 3. So it's a function. So 1 to 1 relationships are functions. Right. Now let's look at 1 to many. Can 1 to many relationships be functions? Now look. 1 is connected to how many? 1 is connected to A and B. So this fails the function rule. Function rule says what? Each element in this set D can only be connected to a single element. But here, this one is connected to two elements. So, one to many relationships are not functions. Remember that. right? Then let's look at many to one. 1 is connected to x, 2 is connected to x, 3 is connected to y. So can this be a function? So 1 is only connected to x, no, and 2 is also only connected to x, so only one element. 3 is also connected to a single element, so it follows the rule each element in this set D is connected to a single element. So many to one relationships are also functions. So we have two types that will give you functions, and it's obvious that many to one, many will fail, right? Many to many will fail because why? One is connected to how many now? A and B. That can't happen, no? So only these two types of relationships gives us functions, one to one and many to one, right? So that is what is mentioned here. Only one to one and many to one relations between two sets create functions, right? And we need to know this notation also. What is this notation? This means what? F is a function from set D to set E. F is defined as a function from set D into set E, right? Now we will define some terms relating to functions. Domain. Domain is the set D. It can be thought of as inputs, okay? Think of it as the input. So set of all possible values which qualify as inputs to a function is known as what? The domain. So x is the inputs. Then they will give an output from the set T. So codomain is called the set of all possible outputs. So codomain is defined as set of all possible outputs. So that is going to be set E. Right. Then range is the set of actual outputs. So remember this. It will be clear when we do an example. Why codomain and range are different terms. Codomain is the all possible outputs. Range is what? Range is the actual outputs. Actual outputs means only the ones connected to an element in D. Right. When we do an example, it will be more clear. Right. Then these are what? Independent and dependent variables are what? A symbol that represents an arbitrary number in the domain of function f is called what? Independent variable. So x is the independent variable. A symbol that represents a number in the range of f is called the dependent variable. So for example, y is equal to x plus 4. So y is dependent on what? X. So x is the independent variable, y is the dependent variable. It doesn't have to be always y and x. You can write different letters. So this one, s is dependent on t. So t is the independent variable, s is the dependent variable because s depends on t. So then t is independent, s is dependent, right? Okay. Now let's do an exercise to understand these terms, right? So let's look at exercise 1. Which of the following relations between two sets represents a function, right? So first of all, we need to decide whether this is a function or not. If it is a function, we need to find the domain, codomain, and range, right? So let's look at the first one, this one, right? So this is what? A one-to-one relation, and all the elements in set D is connected to an element in E, no? So this is what? So 1 is a function. So this is a function because it's a one-to-one relation and all the elements in D are connected to elements in E, right? So then, if because this is a function, we can find what? The domain, range, and codomain, right? Domain is what? Domain is all the inputs. So those are the elements in set D. So what are the elements in set D? 1, comma 2, comma 3, comma 4, right? All the inputs. Then what is codomain? Codomain is all the possible outputs. So here all the possible outputs are the set T. So 5, 6, 7, 8. 5, 6, 7, 8. Then what is the range? Range is all the outputs that are connected to an element in D. So 5 is connected to 1, 6 is connected to 2, 7 is connected to 3, 8 is connected to 4. So again, here codomain and range are the same thing. Actual outputs match the all possible outputs, right? Then let's look at our second relation. This one fails the function test. Why? This is our set, no D, no. Look at this element. This element is not connected to an element in E, so not a function. If it is not a function, we don't need to worry about domains, range, or codomain. So this fails the function test because this element is not connected to element in E. Every element in set D has to be connected to exactly one element in E if it is a function, right? Now let's look at 3. Is it a function? Let's decide. First of all the elements are connected. This is what type of relationship? Many to one. So many to one is okay, no? 1 is only connected to A, 2 is only connected to A, 3 is connected to D. So this is a function, right? Then we can find domain, range, and codomain, right? What is the domain? All the inputs 1, 2, 3. What is the codomain? Codomain is all possible outputs, not only the connected ones. A, B, C, D. So all the elements in E are part of the codomain. So A, B, C, D. So that is all possible outcomes or outputs. What is the range? Range is only the connected ones. So only A and D are connected. So range is now A comma D. Right. So there's the difference. Codomain is all possible outputs. Range is only the connected ones. So sometimes range will not match codomain. In the first one it matched, but in this one it doesn't. Right. Then the last one. So can this be a function or not? Let's look at the first element. 1. 1 is connected to how many elements? 5 and 6. So it can't be a function. Why? Function rule says one element in set D can be only connected to a single element in set E. So not a function. Because 1 is connected to 2 elements. So it fails the function test, right? So we are done with the first exercise, right? So now let's look at another exercise. Right now, in this exercise, the function is given in algebraic form. Normally, all the questions you are going to deal with are going to be this type, algebraic functions, not this type. So you will be given a function like this, an expression. Then we are supposed to find these function values. Function value at 2, function value at -2, function value at a, function value at -a, function value at a plus 1, a squared, and a plus h. Right. So this is the method. So remember this method, very easy. To evaluate a function value, what do we need to do? What is our input variable? X. Inputs are x, outputs are fx. The input variable, replace the input variable in the formula with the value provided. Okay, remember this. So let's do first f of 2. So what should I do? Anywhere I see an x here, I have to replace it with this number inside, number or whatever expression. So there's x here, no? So that x I have to replace with what? The number. So x squared, so 2 squared, minus this x again I have to replace with this number, 2, plus 2. Then just simplify. 3 times 4, minus 2 and plus 2 cancel. So f of 2 is what? 12. So very simple. Whatever number here, you put it for x. Wherever you see an x, you put whatever number inside the function, or number or whatever expression. So let's do -2. So then anywhere I see an x, I have to replace it with what? -2. Now simplify. What do you get? 12 plus 2 plus 2, 16. Right. Then the next one. Now it's not a number, it's just a letter A. So anywhere you see X, what do you need to do? Replace it with A. That's all. So we can't further simplify this, so we'll leave it like that. F of A is what? 3a squared minus a plus 2. Then f of minus a. Now anywhere I see an X, I'm going to replace it with what? Minus a. This one we can simplify a little. Minus a squared becomes plus a squared, minus minus a becomes plus a plus 2. Right. So then next one, f of a plus 1. So again, same thing. Anywhere you see an x, you have to replace it with whatever's inside, a plus 1. Right. This one we can simplify a little. A squared plus 2a plus 1 minus a minus 1 minus 2. Then again simplify. 3a squared, 6a minus a cancel, 5a plus 3. This is plus 2. So this is my plus 1 plus 3 plus 4. Right. So you get that. Right. Then the final one, f of a plus h. So anywhere I see an x, I am going to replace it with a plus h. And now get rid of brackets and simplify. So we get 3a squared 6ah plus 3h squared minus a minus h plus 2. Right. Okay, so that is how you evaluate function. So remember the method. Input variable replace with the value provided. So whatever number here, put for x. If it is not a number, instead of a number, you get an expression, substitute the expression. That's all, right? So after we learn how to evaluate functions, now we need to know how to find domain and range of functions given in algebraic form, right? So let's go through this statement. So this is how we are going to do this. Domain includes all inputs. So what possible x values you can do is the domain. So any input that will give you an output is part of the domain, right? Range is the set of output values, right? So let's start with the first one. Y equals 4x plus 5. So the inputs are x, outputs are y. So let's look at this. If I put a positive number for x, what happens if I put a positive number? So for example, I can put 1, then I'm going to get a output, no? Similarly, if I put a negative number, again I am getting an output, right? I can put 0 also, no? And still I am getting an output. I can do fractions also. I can put a fraction half for x, and I am getting what? A number back, an output back. So positive numbers work, negative inputs work, 0 works, fractions work. So then any number I can put here and get an output back. So any real number works as an input, because I'm always going to get an output for any number I put for x. So what is the domain then? Then the domain of this type of function is what? All real numbers. Domain of y is what? All real numbers, right? What is the range? Range are the possible outputs, no? Any real number we can create, no, from here. By putting some x, you can create any real number, any output you can create. So range of y is also all real numbers, right? Then let's look at the second example, right? Now x squared plus 1. So does positive inputs work? I can put 2. 2 squared is 4. 4 plus 1 is 5. So I get output back. So positive numbers work. Put a negative number. Still works, no? If I put negative 1, I get 1 plus 1, 2. 2 as an output. So negative numbers work. Positive numbers work. 0 works. If I put 0 here for x, I get 0 squared plus 1, 1. So again an output is there. So this one also, what is the domain? All real numbers, because any real number will give you an output, right? This one we have to be careful about the range. Can you get all real numbers as the range, or is it different? So now look at the function itself. So what do we know about x squared? X squared is always going to be greater than or equal to 0. And if you add plus 1 to that, that is always going to be what? Greater than or equal to 1. So then what is the range? The smallest value the range can get is 1. So the smallest output is 1. So range is what then? Range is all numbers greater than or equal to 1. So I wrote it in interval notation that we will learn later on. So in number line, it's going to be what? You mark 1 with a colored circle or colored dot and color the right hand side. So everything greater than or equal to 1 works as the range, right? Okay, then let's look at number 3. So number 3 also domain is clear now. It's similar to the first two. Any real number works. If you put a positive number, you get a output back. If you put a negative number, you get output back. Zero also works. So domain is all real numbers. Now the range you have to be careful because of this x to the fourth power, right? What do we know about x to the 4? X to the 4 is positive, right? Positive or 0. Then because of this minus sign, minus x to the 4 is always going to be what? Less than or equal to 0 because of the minus sign, right? Then you are subtracting 6 from that. So then this is always going to be what? Less than or equal to minus 6. This gx is, or the outputs are always going to be less than or equal to minus 6. So this is the largest possible output. So everything else is going to be less than that. Any output is less than that. So then the range is what? So range is negative infinity to minus 6. So in number line, it's going to be what? Color minus 6 and color everything to the left of that, right? So that is the range of gx, right? Then hx, right? Okay. Now we have a quotient, no? So this is the rule for quotient. We can't divide by 0, no? So if anything, any number will make the denominator 0, that is not part of the domain. So look at this. If I put 2, if I take x as 2, what happens? 2 minus 2. So I will get what? 0 in the denominator. Then I will get 1 over 0. That can't happen. We can't divide by 0. So then x equals 2 is not part of the domain. Similarly, if I put x equals minus 6, the denominator will become 0. So then those two values I have to get rid of. So 2 won't work, minus 6 won't work because they will give you a 0 in the denominator and we can't divide by 0. So anything else will give you an output. So what is the domain then? Then the domain is all real numbers except those two values. So all real numbers slash means get rid of. So what are the two values we are going to get rid of? Minus 6 and 2. So that is the domain, right? What is the range? Can I create any output? There's an output I can't create because the numerator is always 1. I can't get 0 as an output. Why? Only way a quotient becomes 0 is if the numerator is 0. So but here numerator is always 1. So only output I can't create is 0. So the range is all real numbers except 0, right? So then the last one, right? Right. So here we have a square root. This is how we find the domain. What type of numbers can we put inside the square root? They have to be what? Greater than or equal to 0. We can't put negative numbers inside the square root. So our expression inside has to be what? Greater than or equal to 0. So whatever expression you have inside, it has to be greater than or equal to 0. Then x has to be what? greater than or equal to minus 2. So the domain is what? Domain is x greater than or equal to minus 2. So in a number line, it's what? Everything to the right of minus 2. And the range is what? So what is the smallest value you can create? Put minus 2, smallest domain value. Then you can get 0 as the smallest value. Anything greater than 0 is the range, including 0. So x is greater than or equal to 0 is the range. So everything to the right of 0. Right. So that is how you find domain and range of these type of simple functions. Right. So the two special cases are this: when it is a quotient, get rid of points where the denominator becomes 0. When it is a square root, whatever's inside has to be greater than or equal to 0 to find the domain. Right. Okay. Now next we are going to introduce couple of function types. One-to-one functions. Right. What is a one-to-one function? So let's go through the definition. A function f is called one-to-one function if it never takes on the same value twice. That is what? If x1 is not equal to x2, that implies what? Function value at x1 can't be equal to function value at x2. That is one condition. Equivalent condition for the star condition is if you take two function values to be equal, f of x1 to be equal to f of x2, that implies x1 has to be x2. Right. So what does this mean? It's easy to explain through these set figures, right? So look at this relationship. This is a what? This is what? One-to-one relation. So each element is only connected to one. Each element is connected to a single value, right? And look, it never take the same value twice. X is only connected to 1, y is only connected to 2, z is only connected to 3. This is also a function, the second diagram, that is what? Many to one. But this is not a one-to-one function because why? 1 is connected to x, 2 is connected to x. So 1 and 2 are both giving you the same output. Because of that, this is what? Not one-to-one. Because 1 and 2 are both giving you the same output. If it is one-to-one, it never takes the same value again. So because of this 1 and 2 are connected to simple x, this is not 1-to-1. Right. In the syllabus you won't get any questions from one-to-one functions. This is introduced only to define inverse functions, right? So then if you are given a graph, there's a test to check whether the graph of the function is a one-to-one function or not. So this is called horizontal line test, right? A function is one-to-one if and only if what? No horizontal line intersects the graph more than once. So for example, let's look at these two curves. These are two curves of functions, two functions. Y equals fx, and let's say this is y equals gx. So which one is one-to-one, which one is not one-to-one? So what you need to do is draw some horizontal lines. And if your horizontal lines intersect more than once with the curve, so here, look, this horizontal line intersects at 3 points. So if it intersects more than once, it's not going to be a one-to-one function. This is not one-to-one. How about the second one? Draw some horizontal lines and see. So here it only intersects at one point. So this is then one-to-one function. So this is how you check whether a given curve is one-to-one or not. Right. This test is called horizontal line test. Right. Then, right, this type of question will not be tested in the exam, but because I gave you the definition, I'm going to do a small question using one-to-one definition. Right. So how to check whether a function is one-to-one or not? So let's do the second one first. It's easy to check whether something is not one-to-one. So if you can factor this, then it's not going to be one-to-one. So here we can factor this function. Why? X is common, so you can take x out. Then I have x and x minus 2 as the factors. Then equal each factor to 0 and solve for x. You get what? X equals 0 and x equals 2. Now substitute those values into the function. What happens? When I substitute 0, I get what? 0 squared minus 2 times 0. So function value at 0 is going to be 0. Now substitute the other value. Function value at 2 is going to be what? 2 squared minus 2 times 2, again 0. So what happened? 2 inputs gives you the same output. This can't happen in a one-to-one function. Only one input can give you one value. So here 0 and 2 both gives you the same output. So therefore this is not a one-to-one function, because 0 and 2 both gives the same output. This is therefore this is not a one-to-one function. Right. So it's easy to check if it is one-to-one or not using this method. So if you can factor it, that means you will find more than one value that gives you the same output. Right. So let's now come to the first one. This one I can't factor now. So then I have to do the definition. I have to use the definition to check whether it's one-to-one or not. So this is how I start. I can use either condition. So I'm going to use this condition first. x1 is not equal to x2. So method 1, I will use star condition. So I will start with x1 not equal to x2. Then I have to show what? Starting from this, I have to show f of x1 has to be not equal to f of x2. Then it is one-to-one. So then I have to create what? F of x1 and f of x2. So I start with x1 and x2. Then I have to first create 2x1 and 2x2. So if x1 is not equal to x2, 2x1 can't be equal to 2x2. And then if I add the same number to both sides, they won't be equal again. If 2x1 is not equal to 2x2, 2x1 plus 3 is not going to be equal to what? 2x2 plus 3. Then what is 2x1 plus 3? That is f of x1. What is this side? That is f of x2. So we have our result. X1 not equal x2 implies what? Fx1 is not equal to fx2. Therefore this is one-to-one function. So that is using the first condition. You can do the question using the second condition also. Second equivalent condition is what? We start with this now. Function value of x1 is equal to function value of x2 and have to show x1 equals x2. Right. So start with f of x1 equals f of x2. So what is f of x1? 2x1 plus 3. And what is f of x2? 2x2 plus 3. Then what can we do? We can cancel 3 from both sides. So you get 2x1 equals 2x2. Then what can we do? We can divide by 2. x1 equals x2. Right. So again, we have the conclusion. This is 1 to 1. So if x1 equals fx2 implied x1 equals x2. So that is the condition for 1 to 1. So this function is 1 to 1. Right. Okay, again, this type of questions will not be asked in the exam. This is just for reference. Right. Okay. Right. Then the next function type, onto functions. Right. What are onto functions? Right. So f is a function from a to b, and f is called onto if this happens. Range of the function is same as the codomain of the function. So look at this figure 1. Here, what is the domain? 1, 2, 3, 4. What is the range and codomain? Codomain is 5, 6, 7, 8. Range is what? Range is also 5, 6, 7, 8. So this type of function is what? Onto. Right. How about this function? Figure 2. Here, codomain is what? A, B, C, D. But range is what? Only A and D. So codomain doesn't match range. So then this is not onto. This one is onto. So domain codomain matches range means onto function, right? Okay. Reason we are discussing onto and one-to-one functions is we are going to next introduce something called an inverse function. Inverse functions depend on onto and one-to-one condition, right? So I'm going to draw the same examples in the last page. So this was what? The onto and one-to-one function. This is one-to-one and onto, right? Then the other one is what? Other one was 1, 2, 3 ABC. 1, 2, 3. A, B, C, D, right? So then 1 is connected to A, 2 is connected to A, 3 is connected to D. This is many to one and not onto function, right? Okay. So say these are f and g. Both of these functions goes from where? D to E. Domain is D, codomain is E. They are going from D to E. So we are interested in knowing if we can get a function from reverse in this. Can there be a function from E to D? Now look, if I reverse the arrows in one to one and on to case, I get a function back. No, why? 5 is connected to 1, 6 is connected to 2, 7 is connected to a single element 3, 8 is connected to a single element in D. So here, if it is 1 to 1 and 1 to, you can have a reverse function from e to d. This type of function is called inverse function. Okay, right. But look at here, in the second case, by reversing, do I get a function? No, because this is not a function, because why? This was not on to no. So here e to d can't be a function. Why? B and c are not connected to any elements in this side. And it also fails this. Why? It becomes what? One to many. It can't happen. A can't be connected to more than one element on the codomain side. So not all functions can be reversed and created another function. So this type will not have an inverse function, the reverse function, right? Only one to one and on to functions can have a reverse function or inverse function, right? Okay, so now we can define inverse functions, right? Okay, so inverse function of a function f has to follow these two special conditions. It has to be one to one and on to function. Then there is a unique function called the inverse function of f, and this is the notation. This is not a power. This is read as f inverse. This notation is f inverse, right? And f inverse function follows this special condition. F inverse of y equals x. This means if and only if. Double arrow means if and only if. So f inverse of y equals x means if and only if fx equals y. So for example, if it is given f inverse of 3 is equal to 4, that implies what? Function value at 4 equals 3. Using this f inverse of 3 equals 4 is same as function value of 4 at 4 is equal to 3. And similarly, if you are given f of 3 equals to 5, you can write what? F inverse of 5 has to be equal to 3 using this condition again. So, right. So, function goes from a to b. F goes from a to b. F inverse goes from b to a. Remember that. F inverse is the reverse function. You are going from b to a. So then, domain of f inverse is going to be what? B, no? That was what? That was the range of f. So these relationships, remember. Domain of the inverse function is the range of the function. And range of the inverse function is the domain of the function. Right. Okay. Right. Now, next we need to know how to find inverse function. That will be tested in the exams. So now we know what is the inverse function. Not all functions have inverses. Only one to one and on to functions have inverses. They can be reversed and you can create an inverse function, right? So how to find an inverse function is the next topic, right? It's very easy if you follow these three steps. First step, whatever function given to you, equal it to y. Next step, you have to interchange x and y variables. Then the last step, whatever equation we get in step 2, solve for y. Then whatever answer you get for y is your inverse function, right? So let me go through all the steps. using this exercise. Right. So what is the first one? We want to find the inverse function of 3x plus 4. Right. So what is step 1? Step 1 is equal the function to y. So function is 3x plus 4. No? Equal it to y. That's all. That's all. Right. Step 2. What is step 2? Interchange x and y. Wherever you see y, replace it with x. Wherever you see an x, replace it with y. So x equals 3y plus 4. So I interchange the variables, right? So step 3 is what? Step 3 is now solve the equation in step 2 for which variable? Variable y. So I can write 3y is equal to x minus 4. Then y is equal to what? X minus 4 over 3. Then whatever answer you get for y, that is our inverse function. So f inverse of x is equal to x minus 4 over 3. So 3 easy steps to follow and you can get the inverse function. Right, now let's do the second one. What is step 1? Whatever function you have, equal it to y. So here function is x over x minus 2. So we equal it to y. Then what is the second step? Interchange the variables. Anywhere you see y, replace it with x. Anywhere you see an x, replace it with y. Right. So second step is also done. Then what is the final step? This is our equation now. You have to solve it for y. So now let's cross multiply and get rid of brackets. And my objective is to solve for y. No? So I am going to move all the y terms to one side, all the other terms to the other side like this. Then take out y. So when I take out y from each term, first term leaves an x, second term leaves a minus 1, right? Now you want to subject y. So what should you do? Divide both sides by x minus 1. So what we are going to do is get rid of x minus 1 from both sides. So divide both sides by x minus 1. So this x minus 1 will cancel with this x minus 1. And you will get y equals 2x over x minus 1. Then that is our inverse function. This is not f inverse, this is g inverse. So inverse function of g is equal to 2x over x minus 1, right? So again 3 easy steps to follow, then you can get the inverse function, right? Okay, now let's do the final one. So y equals what? X squared minus 4. First step, equal the function to y. Second step is what? Interchange the variable. Any y I am going to replace with x. Any x I am going to replace with y. Right. Then step 2 is done. Last step is solve for y. This equation solve for y. So then y squared is equal to x plus 4. Then y is equal to what? Plus or minus square root of x plus 4. And remember, inverse function has to be unique. So you can't have two parts. You can't have a plus 1 and a minus 1. How do we decide which one is correct. That is why this condition was given to you. X has to be what? Greater than or equal to 0. So that means which one are we going to take? The plus one. So f inverse of x is what? Square root of x plus 4. The positive one. Right. So that is how you find inverse functions. Right. Okay. So in the next lesson, we will discuss how to draw functions, how to graph functions. So mainly we are going to graph lines, parabolas, absolute value functions in the next lesson. Right. So see you guys in the next lesson.